Hey everybody. I've had several comments lately on the channel asking me questions about diagnosing engines, GM OBD1s, and a couple of them were, one was related to tuned port cars, and some were related to throttle body injected. So I thought maybe it was time to add a little bit more into my discussion about diagnosing these cars. In particular, my car is an 85 and the tuned port has a mass airflow sensor on it. And so it has diagnostics in a certain way that you do for mass airflow cars. The mass airflow sensor measures the amount of air that you put in the engine, and then the computer with that and some other sensors computes how much fuel they want to put in the air and it gives you an air-fuel ratio. But there are a lot of engines, and the later tuned port cars like 90, 91, 92, and then all the throttle body cars. There are other cars. I had a quad 4 Oldsmobile. It was a 4-cylinder, and that was a speed density engine also. There were a lot of them in this realm in OBD1 years. I thought maybe it was a good time to talk about what is speed density, because it might help you as you're trying to logically go through and figure out what's going on with your car. Speed density is a way of estimating how much airflow is going into your engine without actually measuring it with a mass airflow sensor like I have here. Once you have an estimate of airflow, then the computer, similar to what you have with mass airflow sensor, the speed density computes how much air is coming in, and then it says, I need 14.1 for 14.7 air-fuel ratio, and it adds fuel to get the air-fuel ratio that you want. And it does this, again, without a mass airflow sensor to tell you. So it's a little bit trickier, and it takes a little more calibration. And when I say calibration, I mean, a mass airflow sensor always measures airflow. And when you're estimating airflow, it's based on a number of parameters. So let's kind of walk through that for a minute. So speed density means, one, you look at engine speed. How many times are the pistons going up and down, right? So how much volume should the engine be pulling in based on how fast it's going? And then it uses a MAP sensor, manifold absolute pressure, to measure the vacuum. Now, vacuum is just a different way of reading pressure, right? As the absolute pressure in the manifold goes down, like when the throttle's closed and you're idling, your manifold absolute pressure is low. That's a lot of vacuum. As you go to wide open throttle and you open that throttle up and more air comes in, then your manifold pressure absolute pressure comes up, and there's less vacuum. It's sort of like a fraction that you're flipping upside down. Atmosphere is 14.7 psi, give or take a few hairs depending on your altitude and what day of the week it is and barometric pressure and all. So, you work from that reference point with absolute pressure. Vacuum is how much that absolute pressure is below atmosphere. So they measure the pressure in the intake manifold, which kind of gives you the density of the air, along with the temperature, particularly of inlet air where they can get it, and or coolant temperature, because those will help you tune. But the big lever is your MAP sensor, manifold absolute pressure. Then it gets a little bit more tricky, because they will use throttle position kind of as a check, right? If you want to know how much air is going into your engine, it's how fast is it turning, how far is the throttle open, what's the pressure in the intake manifold, and then this is the basic engine hardware, right? There's a thing in engine engineering they call volumetric efficiency, right? If you measure how fast, if you take a piston, right, and the piston starts at the top of the cylinder and goes down, it's going to draw in a certain volume of air. That's 100% volumetric efficiency. In reality, when that piston's moving fast, you have losses through the throttle, you have losses through the valves, through the ports, and so your volumetric efficiency is never anywhere near 100%. It's always much less than that. And so they map these engines. The engine, General Motors, laboratory engineers, they map the engines so they know what the volumetric efficiency is and how much air should be coming in for a certain speed. Now, in a car like mine with a mass airflow sensor, if I go change the cylinder heads and put different valves on it, or I change the cam, the mass airflow sensor, that picks that up right away and throws it in and says, hey, airflow changed. In this case, your map sensor will still be there. It'll still be measuring how much air came into the engine from a density point of view, but it really can't tell what the volume is because it's only estimating. So if you make certain changes like cylinder heads or cams or whatever that changes the airflow characteristic of the engine, then you got to start looking at, can I burn a chip? What do I have to do to tweak it to make the calibration work to correct the airflow calculation so it's more correct? Now, in truth, the engines have some learning. All of these with computers have a learning function, and especially with closed loop, with an oxygen sensor, they can adapt to a certain distance, right? There's things called block learn, where it looks at the air-fuel ratio coming in from the oxygen sensor, and it can make adjustments to that to bring it back where it belongs, and it stores those adjustments. So it can tweak and learn, and it kind of dials itself in up to a point. And then if it gets beyond that point, you'll start setting codes for being too rich or too lean, or your performance will suffer. Also, don't forget about EGR. Whether it's on or off, that affects airflow into the engine. Next thing is, if you're working on one of these cars, you really need some form of a scan tool. GM did a wonderful job back in the day with, you could plug in the paperclip and you could look at codes, count the flashes on the check engine light. And that's okay. They were also really good if you had the right connectors and a digital voltmeter, digital ohm meter. You could go through and diagnose sensors and see if a sensor was good or bad. But what you couldn't do is do it dynamically, and there are just so many times where you really want to read what's going on live, real time, right? Now, the tool I have, the CP Actron 9690, they were on the market for a while, but I see this is March of 2024, and I was looking before I started this video, and they seem to be on short supply again. I don't quite know why. The sister tool, which is actually identical except for the label on it, is the Bosch OBD 1300, and I saw you could go out on Amazon and buy it, and it was even on sale today for 30% off or so, and that one works just as well. And so I know there's some other tools out there, but I know this one, it works pretty good on these cars. And I've had some feedback from others on the channel saying they bought one and they're happy with it. Or you can get out your laptop computer and you can get a copy of WinALDL, get the USB cable, go back on my channel and look, and you'll see how to set up WinALDL or Tuner Pro RT. You need the RT version to get real-time data. But either one of those tools can log data for you if you get the right USB cable. They take a little bit more setup. I mean, the nice thing about the scan tool is basically you plug it in and you tell it what kind of car you have. It's about a 2-minute thing and you set it up and you go. Whereas the laptop tools are very nice and I use them, but they take a little bit more setup. Somebody asked me a while back, which one do you prefer? And my answer is it depends. When I go out on the road, I always throw the scan tool in the back of the car. If something happens to me out while I'm traveling, I can plug in the scan tool in 2 minutes, 3 minutes, and I can figure out what's going on. I don't always carry my laptop with me. Yet if I want to get in and record data, boy, the laptop's really a big help. Now, into basic troubleshooting, right? Now, remember, we always talk about going in and looking at the computers, right? But remember that your basic engine mechanical systems have to be good. Engine needs to have proper compression. Your ignition needs to be good. And those are the things, cap, rotor, wires, spark plugs, ignition coil. And there are tests for all of those. I can't run, I'm not running a university class here today. I'm giving you about, 15 or 20 minutes probably of things to think about. You may need a shop manual and go dig in further, but these are some things to think about. How do your spark plugs look? Are they clean? Are they dark? Are they, black? Do they have deposits on them? Are all of them the same color, or do you have one of them that's bad? Fuel system, is it in good shape? Is the filter clean? Do you have a good fuel supply? Vacuum leaks. Again, before you get into diagnosing things, check all the vacuum hoses. Brake booster, purge charcoal canister. Make sure all the hoses are good, because a vacuum leak, sometimes even what looks like a small leak in a vacuum hose, will knock your system off, right? You want to make sure your hoses are in good shape. And if you have to replace hoses because you find a bad one, make sure that you get something that's rated as emissions and fuel hose. There's a lot of cheap hose out there for, I'm going to call it windshield washer tubing, that won't take very much in fuel fumes, and it'll deteriorate again pretty rapidly. So you want something that's, like I say, rated as an emissions hose or something on that order. If you got these older engines, most of them have PCV valves on them. Does your PCV valve work? Does it rattle? Is it clean? Any of those things will upset your computer and cause it to not be right. On ignition, I'll just add one in here that I don't have on the chart. Distributor. Somebody asked me, hey, should I replace the distributor? And if your cap, rotor, wires, if your ignition module inside the distributor on these high energy ignitions, and again, I've got a video back from way back when I put the engine in this car, several years ago. What's in that distributor and what'd you replace? I rebuilt the whole thing, pulled it out, replaced the pickup, I did everything and kept the original distributor. It takes a little bit more work, but you can do it. The thing I watched for is, you want to watch for the bearing clearance in the shaft. And I did a check with a dial indicator, as I recall, to make sure that the bushings aren't worn. If the bushings are worn, typically the sign of that is your timing mark on the balancer. When you go to check timing, it'll start getting real wide. I had one go years ago in a small block Ford I had, and it idled okay, it ran okay at low speed, but at like 4,000 RPM, it would just start misfiring and it would drive you nuts. And it took me months to figure out what it was. But when I realized that the timing mark had gotten wide, the bushings were loose, and the shaft was wobbling back and forth and causing the spark timing to go all over the place at high speed. So distributors can give you trouble. Now, typically you're going to have two different directions you're going to go. First is, the engine's too rich, right? What causes it to go too rich? All of these, and I'm going to talk about whether these are tuned port or whether they're throttle body, similar, right? So what can make it go rich? Well, high fuel pressure. So is your regulator good? Is the diaphragm leaking? I'll tell you, I had one here just a couple of months ago, a nephew of mine, and he lives quite a ways away, and we've been, over the period of months, we were troubleshooting one of his engines over the phone. And he was telling me symptoms, and he found it, I didn't. But I just kept kind of pointing him in different directions, and he'd go dig in. And he had a bad fuel pressure regulator. The diaphragm was bad, and it was bleeding fuel, and it would bleed fuel when the engine was turned off. What would happen is he'd come back into a restart, and it would be really rich and smoking. And we were trying to figure out why that was, and I hadn't even thought about the fuel pressure regulator. It's on a, it was on a 2000-ish, V6 Chevy. Look at the fuel pressure regulator, and it ran fine when it was running normally. The leak was fairly slow, but it would bleed into the intake manifold so that he'd get a really hard start when it was warm. Map sensors and manifold absolute pressure. If it reads low vacuum or high pressure, that will cause it to want to feed more fuel because it thinks the air is more dense and it needs more fuel. And again, video that I had a month or two or three ago on a Buick. Now that one had a mass airflow sensor and a map sensor, newer engine. But if you disconnect the map sensor, the engine will try to give you a number, a value, based on the other sensors on the engine, and it won't be as good an estimate, but it'll be an estimate. So if your engine improves when you unplug the map sensor, that's a big clue. Then you maybe want to try and get a new one, or test the old one and see what it's doing. On the Buick that I was working on, it was dead, and sitting in the driveway it was sitting at 14.7 with the engine turned off, and when we fired the engine, it ran really bad. But when we fired the engine and got some speed under it, it never moved off of 14.7. It thought it was running wide open all the time, and it was feeding wide open throttle fuel, even at idle. And, I mean, that engine just smoked like crazy. So let that be a lesson to you, right? Throttle position sensor, too high or intermittent. Now again, the map sensor is probably more primary, but the TPS, if it's intermittent, the TPS a lot of times will tell you acceleration rate, right? You stomp the throttle, it gives you acceleration fuel. So if your TPS is intermittent, giving you a signal that's jumpy, then the engine's going to think you're jumping on the throttle and it's going to try to add more fuel for you. GM puts one in here about high energy ignition shielding that could cause, again, a jumpy intermittent signal on the spark. And that one would seem to be sort of rare, but they put it in there for a reason. And their thing was watch a tach, and if the tach is jumping around and being unstable, then you might be there. Is your charcoal canister overloaded with fuel because the purge system's wrong? And in some cases, you may have to look at the canister itself. Does it smell bad? Has it been, is it full of fuel vapors or even fuel liquid in some cases? EGR open, causing the oxygen sensor to read rich. See, in all of these cases, there are two things. One is it really rich? Or two is your oxygen sensor just thinking it's rich? Sometimes those are hard to tell apart. This one made me think for a minute because I was like, well, I would think EGR open gives you more air and that would cause you to be lean. But no, EGR is taking exhaust that is supposed to have no oxygen in it and sending it back through the engine a second time, so it's neutral. So the oxygen sensor would see that as a deficiency in oxygen or rich, correct? The next one, if you were reading good data on a scan tool, your block learn is down, it should normally, neutral's like around 125 or 128. So if you're down below like 120, 118, you're probably too rich, and your block learn is telling you that you're too rich. And it's trying to take fuel out to make it leaner. Leaking, I want to go back up to leaking injectors. There's a fancy test in the service manual for, particularly for port injected, to do an injector balance test. And it's more complicated than for me to go through right here. But it's something for you to go dig into if you really need to check that out. In the meantime, the other way is go pull your spark plugs out and see, if you got a V8 and you got 8 plugs, and one is sooty and the other 8 are great, well, you got a problem on one cylinder and you might have a leaking injector on that cylinder. If you happen to have a throttle body engine, well then, if it's a V8 or a V6, typically it'll be a dual bore. And each one will feed half the cylinders. And if you look at the manifold runners, if it was a V8, you'll see, if say one injector's running really rich, 4 cylinders, ought to be coloring the plugs different than the other 4. And you should be able to tell based on the pattern in the intake manifold. What makes it go lean? Well, map sensor reading high vacuum or low pressure, and once again disconnect the sensor and see if it makes it better. Low fuel pressure because of a filter or a fuel pump or a bad regulator. A lean injector, kind of the same thing. You know, look at your plugs, do an injector balance test if you need to. Fuel contamination, the service manual cautions that if you have water in your fuel, even small amounts that get picked up, you know, it gets fed in along with the fuel, and your engine will burn it if it's small amounts. But it will come across with making the oxygen sensor see a lean mixture. Exhaust leaks, vacuum leaks. Vacuum leaks affect the way the engine runs. Exhaust leaks will affect air in your exhaust system, which will affect your oxygen sensor and cause it to read lean. Also, don't forget, in these old engines, if you've got a V, normally there's only a single oxygen sensor, and so right here, you know, it's on the left-hand side, so it isn't reading what's going on the right-hand cylinders. It's only reading the ones on the left. So if you have a cylinder doing something odd on the left-hand side, you read it on the O2 sensor. If it's doing it on the right-hand side, it's just going to go. Now, newer ones, OBD2 engines, typically have, you know, with a V8, typically have 4 sensors. It's 2 on the engine, 1 on each bank, and then it's 2 behind the catalysts, 1 on each bank. And because you need catalyst efficiency. Sometimes you'll see just 3 because they'll have a Y pipe and you'll only have 3 sensors, but different deal. Is your air system, AIR, air pump, sending air to the exhaust when you're in closed loop when it shouldn't be? Is your O2 sensor wiring okay or bad? And another clue is your block learn above 140, which would say, hey, I'm running lean and I'm trying to put fuel in it. I already kind of talked about throttle body versus port injected. Just recognize they're very similar, but you know, you got different injector counts, but overall, it's you know, do you inject the fuel at the ports or do you inject it upstream? And how is it mapped to your cylinders? I also got questions about ECMs. It's, what about if your ECM is bad? Should I just, you know, my engine's running bad, should I put in a new ECM? And generally speaking, the advice is no, don't do that. I've done it before. When I was at the end of my rope and couldn't figure out what was wrong, I put in a new ECM in my daughter's car, in her Buick, years ago. Bought a rebuilt. Didn't make any difference. The problem on that car was the crankshaft position sensor was wonky. And the OBD1 version didn't pick it up. And frankly, you probably wouldn't have picked it up without an oscilloscope. Other than I found an online clue from people who were doing diagnostics with an oscilloscope that said, hey, the signal on this is really weird. And you had to pull the damper, and to get to that one was a really tough job. I did it, cured it, not the ECM. If the ECM's bad and it knows it, it'll throw a trouble code. I think on this car it's a 55, but you got to check your trouble code list. Generally, the thing with ECMs is, you know, it's not just a dumb box, right? It's a computer. And it has a microprocessor, which would throw you a 55 or a similar code. And it's a bunch of subsystem circuits, right? You got a driver that drives the injectors. You got a driver that drives the EGR valve. You've got sensor circuits. And if you go through the service manuals, what you'll find is that if you go through the trouble tree and say, okay, I'm going down the EGR driver and the EGR driver's not doing this when it's supposed to, that indicates the ECM, that circuit is bad in ECM. Or if I've got fuel injectors that won't fire, the trouble tree may take you back and say, the quad driver that runs those injectors is bad. Inside the ECM, you need a new ECM. So those things happen, but make sure you go to the service manual and track those things down and make sure that you either have a trouble code or you go through this official service manual for your model. And they're pretty good about it. It's like, if you do this and it works, but you do that and it doesn't, that one says it's a bad ECM, the other one says replace a sensor, fix a wire, whatever. It's very rare to have an ECM bad without a secondary, some kind of a secondary warning. I won't say it's impossible, but it's pretty rare. And generally, either it'll self-diagnose and say it's got a problem, or one of the subsystem circuits will be bad. And if you run the trouble tree, it'll take you back. Those are my thoughts, and I know that probably doesn't get to everything. That's why they publish service manuals, right? But for right now, if you've got an engine, those are the kinds of things to be walking through and looking for. It's, normally it'll be, is it rich, is it lean, are all the subsystems working? And do you have a bad injector? Do you have a bad regulator? It's sort of like blocking and tackling in football. It's just the basics. You gotta chunk through all of them and see where you get. So, good luck on your troubleshooting, and that's all for now.